All right, so some troubles getting this logged on, so I think we should be okay. Everybody can hear me okay, hopefully. Sound like to me the audio was good. So we'll kind of finish off that Module 9 material that we didn't quite get to yesterday. It wasn't on the quiz, but we might see some of this pop up on the exam. I will also start working through these practice problems. So we'll download this, that we'll have this to kind of work from. This is under the Files tab, exam number 2 materials. So tomorrow will be that second midterm exam. It'll be made available at 11:15. Excuse me. It'll pop up under the exam 2 materials kind of heading. It's going to require that lockdown browser. So once again, if you haven't, make sure you run that test quiz today. I would hope you've done it before then. Now you had to use it for that 7-7 quiz. So if you've already done it there, whatever device you use there, make sure you're using it for the midterm. You should already have it downloaded, ready to go. Once you start that exam, you'll have an hour and 15 minutes to complete it. So whatever time you start, right, between 11:15 and 3:15, you'll have an hour and 15 minutes. That means you must start it by 2 to have the full time. No kind of late submissions are accepted, so you must make sure you're starting it at 2 if you want the full hour and 15 minutes. Okay. It'll cover modules 5 and 6, which we combine together. Module 7, so all of these materials. Module 8, Module 9. So the Module 9 and 10 quiz, as well as those participation quizzes from those 2 modules, all due by the end of the day today. Right. Once again, 11:59 Eastern Standard Time. So make sure you're getting those submitted before the end of the day today. And then kind of tomorrow we'll have that second midterm exam. Okay. It'll be a mix of multiple choice, short answer, not short answer, like fill in the blank, and then some numerical response. Right? Any logistical questions for me about the exam before we dive in? And we won't have a participation quiz today. It's just going to be review. So this is really just, me getting able to kind of field questions from you guys and kind of give you some review problems to look at before you go to take that second midterm. Questions? Okay. So before we kind of start fielding questions from that practice exam, we left off last class, and I introduced this idea of there's different types of markets, and some of them are more concentrated in those. When we say more concentrated, that means a larger percent of the market share is with a smaller number of firms, the most extreme being a monopoly. So we have this 4-firm concentration ratio. We said if there's ever 4 or fewer firms, if we add up the market share of the top 4 firms, well, that's going to be the entire market share if there are 4 firms or fewer. So that would always be 100%. So we can't really make differentiations between 1 firm, 2 firms, 3 firms, or 4 firms if we just use that concentration ratio. Now, for markets that have more than 4 firms, we can kind of see, what do you think about this way? Even if they were all splitting it evenly, if I had 5 firms, each firm would have 20%. That'd be a 4-firm concentration ratio. The top 4 firms, 20 plus 20 plus 20 plus 20 is 80. If we have 100 firms and they all have 1%, 1 plus 1 plus 1 plus 1 is 4. So the lower the concentration ratio, that 4-firm concentration ratio, the more competitive it is. Okay? So you could think about, let's say I had something like this, where I give you the top 4 firms, and then every other firm in this industry. How would I find that 4-firm concentration ratio? Well, how do I find their market share? I would find the total, right? Add up the top 4 firms, divide it by the total, and then multiply it by, I guess technically here, I should have had to add in, to scale it up to a percent, that 4-firm concentration ratio should be in terms of percentage. So whatever the proportion of total sales, so just adding up the total sales in this market, the top 4 firms have, multiply that by 100, would give me my 4-firm concentration ratio. So we could see this market at 40%. It's not the most concentrated, but it's not the least either, right? It's somewhere between that 0 and 100, okay? If instead I had an example like this, what would it be? Well, this one's kind of easy. Here's the top 4 firms. If every other firm only has 0.1%, then the top 4 firms, when I add up their market share, 99.9%. This would be a heavily concentrated market. So I tried to grab this. I think that it's a little bit old, might be from like 2001 21, 22. But this was kind of the market share of the top 4 operating systems for phones. So this would be a very concentrated market, or we don't have near as much competition. Okay. I just have a list here. Here's some different industries we can think about. Video game consoles, there's only a handful of major companies. And so there we actually end up with a 4-firm concentration rate of 100%. Things like automobiles, there's a couple major players, but we don't have, just 2 or 3 firms. We've got quite a few different automobile makers. There we got that top 4 firms has just about 80%. Okay. So the next thing that we'll talk about is this other measure of concentration, which is a little bit, shouldn't say better, but it allows us to make more differentiations between types of markets. So we're going to take the market share of every firm, right? We're going to square it, right? And then add up every single firm's market share. Now, obviously, I'm not going to give you an example on the exam where I've got like 100 firms. This would take a long time, right? But I might give you an example where we have a small number of firms and we can find what that HHI is. Okay. So if I take these market shares in terms of percentages and square them, the highest I could ever see is if I had a monopoly, what would the market share be? 100%. If I square that, right, I get what? 10,000. So if I only have one firm or a monopoly, I'd have an HHI of 10,000. Now, if I have 2 firms, and let's say they're splitting it evenly, because I'm squaring these values, the HHI is really going to penalize having a lot of market concentration in just one firm. So here, 50 squared plus 50 squared, I have what? 2,500 plus 2,500, or 5,000. So this was 2 firms splitting it evenly. So here's one advantage of the HHI, is it doesn't just pick up like how many firms there are. Let's say I had 2 firms, but one of them has 90% of the market share. So here I'd end up with what? Well, I'll do this in order. 100 plus, this would be what? 8,100 or 8,200. So I still have 2 firms, but the HHI is telling me one of those firms, because it has 90%, it's like getting over penalized. Like if 1 squared is 1, 2 squared is 4, right? And then 3 squared is 9. So squaring it makes that number that's getting added into that HHI much, much larger. So here I can even differentiate between markets that have the same number of firms, but a more uneven distribution of the market share. Okay. So that's going to be our main advantage of that HHI, is we can really differentiate between any type of market, even if it has the same number of firms, but different kind of breakdown of market share, we can kind of make that differentiation. So here I've got an example, and let's just say I treat that 5th all other firms as one firm. How would I find my HHI? I just go through each firm's market share, square it, add them all up. Right? So this one, when we had the 2 firms sharing it evenly, I think I had an HHI of what, 5,000. So when I have 2 major firms, and yeah, there's other firms here, but they don't have a very large market share, notice I get an HHI that's a little bit less than 5,000, but not that much lower, right? Because I still have an industry that's heavily concentrated with 2 firms. So just some examples. I kind of already walked through the monopoly and the other 2 firms. We'll kind of look at some problems from the practice exam here in a second to kind of look at additional examples. But just to show you, if I look at the video game console market, 4-firm concentration ratio would be 100%. But if I calculate the HHI, right, it's now not going to be 100%. It's not going to be 10,000. It won't be the same as a monopoly, right? So it allows me to identify, yes, this is a heavily concentrated market, but it's not just one firm, right? There's multiple firms, and there's kind of this break, they're all splitting the market share here. Another operating system one that kind of shows just the visual here. Once again, I think this is just different. I think this was for instead of, what was this? Probably computers instead of phones. I don't know, but it's slightly different breakdown. Beer producers, you have 2 major players, but then a lot of other companies, right? So this HHI, we could go through, square every firm's market share, add them up. A less concentrated, here we've got several major players in the automobile industry. We have a lot of smaller players. So all of these, we could kind of use these market shares to calculate the HHI. So let's look at maybe the types of problems that you could be asked about this on the exam. So I'm going to scroll down here just to kind of get what we're talking about. So let's say I had kind of your major kind of phone companies here, and I'm kind of making this data up. This one I didn't actually pull from online, but it's somewhat reflective of reality. So let's say I wanted to know what's the 4-firm concentration ratio of the market above. Well, I'm not just going to add up the first 4 firms. It's the top 4 firms. So I would take the market share, the highest market share, next highest, next highest, next highest, add those all up. If I do that, I should get 96%. Okay. So this is a heavily concentrated industry, right? And that 4-firm concentration ratio, it looks very close to 100. So it looks like it's close to a monopoly. But when we look at the actual data, we know that it's not, right? Because we can't make a differentiation between a monopoly and say 4 firms sharing all of market share using that 4-firm concentration ratio. So I would, if studying for the exam, focus a lot more, wink, wink, on this HHI. So how would I, and I didn't have, I should have got rid of this. I think I changed the example to make it more clear. Let's just say I gave you 5 firms and I didn't group all the other firms into one. Excuse me. If I wanted to find the HHI of this market, what would I do? So I would take every single market share, square it, and add them all up. Okay. So 46 squared. So here I'll, this will help me out for later on in class as well. I'll use Excel to be my calculator here. So all I'm going to do is take 46 and square it. Oh, be helpful if we could see the values here on the screen. There we go. I'm going to take 32 squared, and then going to add in 4 squared, 10 squared, plus 8 squared, right? Just taking that market share in terms of a percentage, squaring those values, and I'd end up with an HHI of 3,320. So it's not only the top 4 firms. So notice, if I were to only take the top 4 firms, I left out Lenovo here, there I end up with 3,304. That's not my HHI. My HHI doesn't take just the top 4 firms. It takes every single firm, oops, sorry, in that industry. Okay. Any questions on that? Okay. All right. So that kind of rounds out or finishes out module kind of 9. Are there any specific questions that people have on this practice exam? If so, I will kind of start working through those. So you want to do some older stuff, newer stuff. Nobody has any questions? Don't be shy. All right, let's see. 25. I sure can. So let's look down here. Okay, this is a good one, right? In fact, I'm going to work through these 3 because I think these will be some more of the difficult ones. We'll eventually get to 25, but it's all related to kind of this idea of marginal utility, prices, and thinking about consumer optimum, okay? So let's say we have this example and someone's spending $20 on 2 different goods. So that's their income. They've got the price of both of these goods are $1 and $2. Margin utility of the last good consumed is 10 and 15. If we should be maximizing our total utility, what should this individual do? Okay. So here, it doesn't matter necessarily which good I put on my x-axis. I'll do, well, just to make this a little bit trickier, I'll put hamburgers on my x-axis here, right? So if I'm thinking about quantity of hamburgers, and then I had kind of pops up here, got the price of pop was $1, price of a hamburger was 2, and the income, or M, we usually kind of notate income with M, is 20, okay? And then the margin utility of the last hamburger consumed was told to us to be 15. Margin utility of the last pop was 10, okay? So if I was building out my budget constraint, where would this be? Well, The intercepts are going to be, if I'm only buying this good, how much can I afford? So if I was only buying pops here, I have $20, divide that by the price of that good, so 20 over 1 would be 20. What if I was only buying hamburgers? Well, there, income over the price of a hamburger, 20 over 2 would be 10. So I've got, there we go. That's my budget constraint, all right? Now, what should the slope of my budget constraint always be? So even if I didn't draw this out and calculate these quantities, we said the slope of our budget constraint should always be negative whatever the relative price of good X is to the price of good Y, okay? So in our example, this is negative price of hamburgers to pop. So I've got what? 2 over 1 or negative 2, okay? Everybody with me so far? Now, we know that the point where consumers are spending optimally will be wherever the highest indifference curve, we could put some value to this, the highest indifference curve we can get to given our budget constraint. So at that point, the slope of our budget constraint should be the same as the slope of our indifference curve. Well, we just said the slope of the budget constraint was negative 2, okay? So the slope of our indifference curve, that is the marginal utility of good X negative over the marginal utility of good Y. Or for us, marginal utility of hamburgers over the marginal utility of pop. So here I've got what? The marginal utility of a hamburger, where are we at? There we go. So this was 15 over 10 or negative 1. Okay, these aren't the same, okay? So we know that we're not at this point. What point are we at, right? Well, we're actually at a point where the slope of the indifference curve is flatter, right? It's a smaller negative value. So we know that we're somewhere over here, right? Where that slope is flatter than the slope of the budget constraint, okay? So what should I do? Well, should try to move to that consumer optimum because I can't afford this point, right? In fact, if the slope of the indifference curve is here, I must be on a lower indifference curve, okay? So another way of thinking about this, and hopefully we can kind of see here, I should be buying more pop, fewer hamburgers, but probably, the visual is helpful, but you kind of have to know how to build that. It wasn't given to us. Another way of answering a problem like this is just knowing that we should be consuming where the marginal utility of each good per dollar is exactly the same, okay? So if we plug in our values, we had what? 10 over 1, and this was 15 over 2, okay? So these are not, in fact, equal. 10 is greater than 7.5. So if I'm getting a higher marginal utility per dollar from this good, what should happen to the quantity of that good? I should buy more of that good, less of the other. Same thing the visual told us, right? If you ever have the margin utility per dollar being higher for one of the goods, you should buy more of that good, less of the other good, okay? Now, as I do that, I don't think this was part of the question, so just to kind of, before I add some additional stuff in, yeah, so there I should buy more of those Den Pops. Oh, where are we at? More Den Pops, fewer hamburgers, okay? Also, in an example like this, if I'm thinking about spending all of my money, when I buy more of something, I have to buy less of something else. So the ones where we have them moving in the same direction really doesn't make a lot of sense, okay? What did I want to say here? Oh, so why does, as I buy more of this x-axis good, or sorry, no, less of the x-axis good, more of the y-axis good, what's going to happen? Well, as I buy fewer hamburgers, the margin utility of the last hamburger is going to go, what? Up. When I have fewer of something, the margin utility of the last one is going to be higher. As I buy more of something, the margin utility of the last one I bought is going to be lower. So notice this is going to go down, this is going to go up until we get these two to be exactly the same, okay? Any questions on that before we keep moving here? And I'll get to 25. All right. So 24 here. Let's say I have kind of a similar example, and we're thinking about shifts in this curve. Right? So I've got $50. I've got two goods, $3, $1.50, coffee and gas. If the price of gas doubles and the price of coffee also doubles, what's going to happen to the budget line? Okay. Well, remember, we don't even have to go through and work this out completely. If I've got, and it doesn't really matter, I don't think I even told you which good is on the x-axis here. Yeah, I didn't, right? So I can kind of pick and choose, and it ultimately won't matter. So I'll draw both of them out. So let's say I put gas up here, coffee down here. Okay. What would the slope of my budget constraint be? Well, it's the relative price of good X to the price of good Y. So the price of a cup of coffee to the price of a gallon of gas. In our initial scenario, this was $1.50 and $3. So we have what? Negative 1/2 was our slope. If the prices change and they're now $3 for a cup of coffee, $6 for gas, what is the slope? Still negative 1/2. However, remember, these points, we're taking all of my income and dividing it by the price of that good. So if the price of both goods went up and they went up by the same proportion, my slope stays the same. But what's going to happen? If my denominators are larger here, I'm actually going to end up with fewer of each good if I'm only buying that good. So when we have decreases in the price of both goods and their proportional changes, we still have the same relative prices. This is going to look like a decrease in income, right? Because even though income didn't decrease, we can kind of think about what do these points represent? Real income. So even if my income stays the same, but prices go up, we said real income is going to go down. So income decreases or price increases in both goods would cause this kind of downward shift. Now, let's just, for the sake of this example, let's say the prices, instead of 6 and 3, let's say the price of gas goes to, I don't know, 4, and the price of a cup of coffee, I don't know, goes to 3. Okay. Well, now both prices went up, right? So actually, I wouldn't give you one this difficult, but here, I'll give you one that I would actually ask you on the exam for making this worthwhile. So let's say the price of coffee goes to 2 and the price of gas stays at 3. Right? Now, what is our relative price? It's going to be negative 2/3. So 2/3 is a little bit larger than 1/2. So what's going to happen? We're going to get a steeper slope, right? Now, the price of gas didn't change. So if I'm only buying gas, that point didn't change. But if I'm only buying coffee now, because its price is higher than it was before, we're going to see that point shift downward. And our slope, negative 2/3, we're going to have a slightly steeper budget constraint now. Okay. So I could give you the change in the price of one good. If I give you a change in the price of both, it'll probably be something where they're shifting the same amount. Could also have changes in income, right? That shifts our budget constraint upward or downward. And we're thinking about when I only have one price change, it's not only going to shift my budget constraint, it's actually going to cause it to become flatter or steeper. In this case, steeper. Okay. All right. So that one was what? It just shifts down. Okay. Has the same slope. So what if instead, and I can guarantee you'll see a problem like this, where I give you two goods, and now we want to decompose the total effect of a price change in one good into the substitution and income effect. So we want to decompose them into both. So we've got what? $100, currently buying what? 10 packs of ramen noodles, 5 ounces of caviar. So we saw a price decrease, and the resulting new utility maximizing point is 12 and 4. Which of the following must be true? Okay. So we could kind of start out, we could draw this. So we've got And here, I don't think I even specified what good is on the x-axis. Again, shouldn't matter. So we'll put, it doesn't really matter. I'll do caviar down here, ramen noodles up here, okay? So whatever consumer optimum we were at before, we were told that was, what, 10 packs of ramen, 5 cans or whatever ounces of caviar, okay? I then saw a price, where was, of ramen noodles decreases. So we can start to think about what is that going to do? Well, if the price of ramen noodles decreases, I know my new budget constraint, if I'm only buying caviar, that point doesn't change. However, if I'm, oh, nope, it's a price decrease. I did this wrong, right? Because if the price goes down, what's going to happen? I can actually buy more ramen than I was before. Okay? So you could do this as a price increase as well. Here, this problem actually had a price. I'll draw one out as a price decrease or increase in a second. So what's going to happen is the slope, right? Remember, relative prices, right? So it's the price of caviar to the price of ramen here. If the price of ramen goes down, dividing by a smaller number, my slope, it should become steeper, okay? Now, I don't have to have this visual, but I was told that after this price change, we did what? We bought 12 packs of ramen and 4 ounces of caviar, okay? So our new consumer optimum, right, the new indifference curve we were on was going to be somewhere up here, okay? So that's the total effect, okay? So in between, we could draw this hypothetical budget constraint, but we can also just use kind of shorthand. We said we know that if the price goes down, what's going to happen to my real income? So we said we can think of real income as just income over price. So if prices go down, my real income goes up. Okay. Now, before we even think about real income, the substitution effect for both goods, we should be able to determine, right? When ramen is now cheaper, we should substitute towards whatever is now relatively cheaper. So we should buy more ramen, less caviar, right? That's our substitution effect. What's our income effect? Well, we said we have a real income increase. We would need to know whether or not these goods are normal or inferior, okay? So I told here ramen noodles are inferior, caviar is a normal good. So if caviar is a normal good, when I have higher real income, I'm actually going to buy more of it. But if I have an inferior good, I'm actually going to buy less of it, right? So if I think about the total effect here, well, the substitution and income effect are pushing each of these quantities for both goods in different directions. Without any more information, I don't really know what that total effect is. Now, because I was given it in the problem, I was told that the amount of caviar actually goes down, and the total effect, the difference in that consumer optimum point for ramen, it went up. What do I know has to be true for caviar? Well, for caviar, it must be that that substitution effect was greater than the income effect. That's the only way I kind of end up with this it's the only way I end up with this decrease in caviar. Okay. Now, what about for ramen, right? Well, I know the total effect is positive, so which of these must have been larger? Well, it must also be that that substitution effect for ramen was greater than its income effect as well. Okay? So in this problem, I told you from the information what the total effect was. You could figure out, right, using this idea that price decreases will cause us to substitute towards what is relatively cheaper now, but it also causes an income effect change. If we have more real income, I buy more normal goods, less of inferior goods. And then knowing the total effect, that would tell me which one of these had to be larger. Okay? So if I'm thinking about which of these are what? Incorrect. So we said the substitution effect for caviar was negative. That one's correct. Substitution effect for caviar must be greater than the income effect. We said that one was true as well. The income effect for ramen noodles is negative. That one was also true. So the income effect for ramen noodles is greater than the substitution. Well, no, there we said the substitution effect was also greater than the income effect for ramen noodles. Excuse me. So the one that is incorrect would be answer D. Okay. Any questions on that one before we keep moving here? Okay. What if, do another one. So I don't have the total effect here, but we can work through one that allows us to identify income versus substitution effects. Okay. So it doesn't matter what the other good is. Let's say we've got some good and it's a normal good. It's an old example. I pulled iPods. I don't even know if they still sell them to this point. Probably for little kids to keep them off the internet. So an iPod is a normal good. We've got an increase in the price. What will be the income and substitution effect? Okay. So I'll walk through a couple different examples here. So we'll use this one. So let's say we had price of this good. No, I already forgot. Was it went up? Yeah, it said it went up, right? So if I have a price increase, right, immediately before I do anything else, I can always determine what the substitution effect for a good is. Whatever good I'm looking at, and this is, any other goods, right? If the good I'm looking at, the price goes up, I'm going to buy more of other goods. They are now relatively cheaper, fewer of the good that is now more expensive. Okay. So I've got my substitution effect. Now, if this is a normal good, when I have this price increase, what's going to happen to my real income? Well, we said real income is just income over prices. So when the prices go up, my real income goes down. So for a normal good, if I have less money, less real income, I'm going to buy less of it. Now, I would need to know what the other good is to know what the income effect for it was. In this case, this question, we weren't asked about that. So here, if the income and substitution effect are both causing the quantity of this good to decrease, we know for sure the total effect of that price change will be that it decreases. Okay. So just to work through a slightly different one, and this could be any good. Let's say I've got the price of any good X, and let's say it goes down, but I'm told that this is an inferior product. Okay. So the substitution effect, okay, and I could think of maybe X is inferior. Let's think about if I have Y, some other good, and it's a normal good. Okay. So the substitution effect is going to be I always buy more of what is relatively cheaper. So I would buy more of that X good because the price is lower, which means if I'm spending all of my income, I have to substitute away from other products or this other good Y. The income effect, we said if prices go down, what's going to happen to my real income? Well, if my real income is just my income over price, when prices are lower, real income is actually going up. So the income effect for X, if it's inferior, I have more income, I'm actually going to buy less of it. Now, for normal goods, these other products, Y, when I have more money, I actually buy more of them if they're normal goods. So what would the total effect for both of these products be? Well, in both scenarios, I don't actually know unless you tell me whether or not the substitution or income effect is larger. So some of these, I don't think there was one on this specific practice exam, but we worked through some on the quizzes and in class. Sometimes you could be asked about what the total effect is, not just the income and substitution effect. And sometimes the answer for the total effect is it's indeterminate. Now, the income and substitution effect, those will always be that it either increases or decreases. You don't have to worry about an indeterminate answer there. The only thing that you might have an indeterminate as a possible answer for is when the income and substitution effect push the quantity in different directions. There, then, the total effect you could end up with being indeterminate. Questions on that one? Okay. All right. So, any other questions that people want to see worked through before I start kind of just picking and choosing? 20, yes. 20. Okay. So we've got prices. Okay. So 20 is going to be related to this idea that we know that the consumer optimum is where the slope of our budget constraint is the exact same as the slope of our indifference curve. Okay. So we said whatever two goods we're looking at, and here we got what? Textbooks on my x-axis, pizza on my y-axis. I'm told the price is 60, 20, income is 100. So we've got, let me just write this out. Income 100 before we switch back. So price of textbooks is 60, price of pizza is 20. Okay. So initially, all right, if I'm thinking about what my indifference curve is, I don't have to do this every single time. So I could just know that I'm going to have some budget constraint and there's a trade-off between these two products. I know the slope will always be negative the relative price of my X good to the price of my Y good. So my X good here was textbooks, my Y good was pizza. So I know that my slope should be -3. Okay. Now, the idea of consumer optimum is that I've got all these different indifference curves. Every point above my budget constraint, all these points are unaffordable. Every point below it, I'm not using all of my resources. Okay. So even though I can afford this point and I'm spending all my money, I'm on a lower indifference curve than if I was at this point where I'm spending all of my money, but I'm on a higher indifference curve, right? So this will be our consumer optimum. And what we said is that the slope of that budget constraint, so this was going to be the price of our textbooks over the price of pizza, which we said was -3, should be the exact same at that point as the slope of our indifference curve, which is going to be the ratio of the margin utilities of both goods, and it's still the X good over the Y good. Okay. So I know that my marginal rate of substitution should be the same as that relative price or -3. However, when we talk about the marginal rate of substitution, it's already in terms of the amount of the other good we have to give up. And so we generally kind of ignore that negative sign. So the marginal rate of substitution, and I won't ever try to trick you with like negative and positive answers. It would look something like this, right? Where when we talk about the marginal rate of substitution, it's only positive. Okay. So there it should be 3. Okay. Any questions? I actually add in something that I could ask you here. Another wrinkle in this problem. Let's say we had the exact same setup, but I instead told you that the margin utility of the last textbook was, oh, make the math easy on myself here. So I want it, was 120, right? And I asked you, what must the marginal utility of the last pizza be? Well, if you know that the slope of the budget constraint is equal to this marginal rate of substitution, well, then I know that -3 must be equal to 120 over that margin utility of the last pizza. Now it's just a little bit of algebra, right? I multiply both sides by the margin utility of pizza, divide both sides by -3. Now, once again, because we're looking at this marginal rate of substitution, I'm going to end up dropping this negative sign, right? So I have the margin utility, running out of room here, of pizza must be what? 120 divided by 3 or 40. Okay. So I could also kind of do something like that where I ask you, I give you the prices. Instead of asking you for the marginal rate of substitution, I give you the marginal utility of one good because you know those relative prices should be the same as that marginal rate of substitution in absolute value. You could back out what the marginal utility of the other good must be. And in fact, you could do it this way, or you could also think about what? I know that when I'm spending optimally, the marginal utility per dollar of both goods should be the same. So if I have textbooks were 60, margin utility was 120. Here, I don't know the margin utility of pizza, but I know the price was 20. Similar idea. It's just a little bit of algebra. I get what? 2 times 20. And sure enough, I end up finding the same thing, which is that the margin utility of pizza must be 40. Okay. It's just different ways of kind of solving or thinking about the same problem there. Kind of work through the original one, but also, something I could change, something else you could potentially see. Okay. Any questions? Yes, here, I should have. Didn't leave this up before so. Any other questions on that one before we keep moving, or any additional problems you guys want to see worked through here next? Okay. So let's think about, there we go, 21. Okay, so I'm thinking module 8 is probably going to be one that's tough. So we've got prices, margin utility. This is basically similar to the last one I asked. But in terms of not actually coming up with a value, I'm just asking you, is it less than, greater than, equal to, twice as large? So I've got price of, I'll write this down before you go. So price of a video game is 40. And this is how I would solve these problems. I'd write out what I'm given. So I've got the price of a video game is 40, price of a movie ticket is 10. In order to, when maximizing utility, what must be true about the margin utility of a movie ticket relative to that of a video game? Okay. So this is where I know that when I'm spending optimally, the marginal utility per dollar I'm spending on both goods should be the same. Okay. Excuse me. So if I've got the margin utility of a video game over 40 is equal to the margin utility of a movie over 10, one way you can do this is just think about if the margin utility per dollar of both goods here had to be equal to 1. What would the margin utilities have to be? Well, the margin utility of a video game would have to be 40. The margin utility of a movie would have to be 10. So what must be true? The margin utility of the video game must be higher. So that's, I think, one way of thinking about it is if I were to make the margin utility per dollar of both goods equal to 1, oh, give me 1 second. I've got to take a call here. Hey. Oh, okay. Bye. Sorry, that was my wife, and she's got our son. I was got to do something for him real quick. I'll extend class a couple minutes afterwards to make up for this time. I've got to get on and do something to help her out. I apologize for this. I'll edit this, and I probably won't edit it in post, but. All right. Yeah, maybe. I apologize. I don't usually like to do this, but. Okay. All right. Sorry. So one way to approach a problem like this would be to set the margin utility per dollar equal to 1, and then think of what those values would have to be. That kind of shows you it not only has to be doubled, the margin utility of the video game doesn't have to be twice as large. It would have to be 4 times as large, right? But what I can say for sure is that it has to be greater, right? So if I'm thinking about which of these is going to be the answer, I know the margin utility for movie tickets, oh wait, it's said the other direction. I know the margin utility of video games has to be greater than movie tickets, so the margin utility of movie tickets must be less than that of video games. Okay. I would probably, to be completely honest, be less likely to give you a problem like this on the exam and more likely to give you three of these. So either tell you the prices, tell you the margin utility of one of these goods, and have you solve for the other. Or I would give you the margin utilities, give you one price, and have you back out that. So maybe I would do something like this. So let's say the margin utility of a video game, last video game was 80. Margin utility of a movie ticket was 20. And I told you the price of a video game was 20. And then I ask, what's the price of the movie ticket? And then you know the margin utility per dollar has to be the same. So you just, okay, plug those values in that you know. You have the one thing that you don't know. Now it's a little bit of algebra, right? So this would be 4. So if I multiply both sides by the price of a movie ticket, this was 4. So divide both sides by 4. I see the price of a movie ticket would have to be what? $5 in this example. Okay. Excuse me. So I'd probably more likely to do something like that than ask you to do the twice as large, greater than kind of idea. Okay. Any other questions on that one? Sorry for the interruption there. Any other problems that you guys want to see worked through here? 31. Yeah, this is a good one, and it's more recent. So this is going to be difficult. So we've got 10 units. I tell you the average variable cost, the marginal cost, and ask you what must be true about the 11th unit. So we're in the short run, right? We're told, I'm not told that. Okay, well, this problem should have added that in. I think I was using it from a previous example. So let's say I told you that this was in the short run. Right? This is how you should kind of assume this one. I think it won't ultimately matter too much, but I know the type of question I would ask you. I would give you that this is in the short run for a reason. So let's say I've got this short run. All right, some things I can't change. Right? So I've got my quantity. I can draw out any firm's short run cost curve with the information that we talked about. So we said there's going to be some average total cost, and it has this U shape to it. We said we're also going to have this marginal cost. And what's going to be true is initially, maybe it's decreasing because we have gains from specialization, but eventually it'll start increasing. And the point where it hits or is equal to the average total cost, so the quantity we would kind of call the efficient quantity or the efficient scale of production, was where the marginal cost was equal to the average total cost, and that was at the minimum of our average total cost curve. Okay. Now, if I have average variable costs, what has to be true is if I am in the short run, I've got some fixed costs, so my average variable costs will be somewhere below the average total cost. Now, the gap in between my average total and average variable cost is my average fixed cost, but we said as we're producing more, and we generally won't draw the average fixed cost curve on here because it doesn't really do a lot for us at this point, and we just don't want to muddy up the graph. But that gap in between is our average fixed cost. As we produce more units, the average fixed cost just keeps going lower and lower, so that gap is getting closer and closer. Now, what will also be true is the point where marginal cost is equal to average variable cost will also be at the average variable costs minimum. But because there's always this difference between average total and average variable, that will always be, so we don't really have a name for this, but this is just going to be the quantity where marginal cost is equal to the minimum point of the average variable. That will always be at a quantity lower than the efficient scale. Okay? So we're told that currently we've got 10 units, average variable cost is 20, and the marginal cost is 18. Okay, so I know that at this quantity of 10, right, I've got an average variable cost. So whatever quantity I'm at, the average variable cost is above my marginal cost. Right? So the average variable cost was 20. My marginal cost here, obviously not drawn to scale, but 18. Okay. If I want to produce that, so that was at a quantity of 10. If I go to the 11th unit, right, what must be happening to my average variable cost, right? Well, we said anytime my marginal cost is below the average, right, my new average must be doing what? Or my new average variable cost should be going down, right? I'm adding a value that's below the average. This is the idea. If I can do worse on a quiz than my previous current quiz grade, my new quiz grade is going to be a little bit lower. So we know that if we're at a quantity where average variable cost is above the marginal cost, average variable costs are still decreasing. Okay. Now, if I had given you instead, I could do the same thing, but for average total. Let's say I told you that. So actually, before I keep moving, is there any questions on that before I add in an additional type of question you could see, just to give you more examples? Okay. Let's say I told you that you were instead at a quantity where your marginal cost was equal to 40 and your average total cost was equal to 35. Okay. Well, you don't know exactly where that would be on the graph, but you know that it's going to be some quantity where the marginal cost is above the average total. Okay. So if I've got my marginal cost was 40, the average total cost was 35. Well, now I've got a situation where the marginal cost was above the average total. So what must be true if I produce another unit? My new average total cost will be higher or increasing. Okay. So if we think back on the initial one, I know that the average variable cost must be decreasing. So it can't be greater than the old average. It must be less than the old average. Okay. And then what must be true about average total cost? Well, average total cost has to be above average variable. So the fact that thinking about average total being less than 20 doesn't make any sense. The marginal cost must be less than 18. I probably should have added in an additional caveat here, which is that we're on the diminishing portion of our marginal cost curve. That way we know when we produce one more unit, we're going to have increasing marginal costs, right? So I threw this together a little bit kind of quick. I'll be much more careful on the exam. I'll add in these additional kind of assumptions that we typically have. And I won't try to trick you with those. Generally, the type of question like this I would give you, we're assuming we're looking at the diminishing portion of the marginal cost curve. I never gave you any examples where we weren't in terms of asking you the type of question to compare marginal cost to average total, because we know ultimately if we're using this to make our production decisions, we're never going to stop if our costs are going down. So we're really only ever concerned with that diminishing returns portion of the marginal cost curve when it comes to thinking about these efficient scales of production. We talked about gains from specialization more when we were thinking about that marginal productivity of labor curve. Okay. Any other problems people want to see work through here? 8. Yes, let's go up here. Yeah, so I can almost guarantee you that you'll have a problem. And when I say I can almost, I wrote the exam, so I might have some idea. So if you've got an elasticity of demand of negative 0.9, elasticity of supply of 0.5, which of the following, and you can kind of think about this graph above where we have a tax, which of the following is going to be true? Okay. So who bears more of the burden of the tax is always going to be whoever is more inelastic. They're going to bear more of the burden, or their loss of surplus is going to be greater than the other party. So if I'm thinking about, I have the elasticity of demand, I think it was, right? is negative 0.9. The elasticity of supply is 0.5. So this is where we have to know a little bit of something about the elasticity of supply and demand back from module 4, which is that even though this is always negative, when I'm comparing if it's more or less elastic than supply, well, I know that this will always be positive. I'm just comparing the absolute value, right? So here I'm just saying is the absolute value for the elasticity of demand, which is 0.9, that is greater than the elasticity of supply. So the higher the elasticity, that tells us people are being more elastic, they're more responsive. So who is more responsive or who is more elastic here? That would be our demand or consumers. Who is less responsive or so who is less elastic, or we would say if you're less elastic, you're more inelastic. That would be our producers or our suppliers. So who's going to bear more of the burden? Whoever is more inelastic, right? They're not avoiding the burden. They're not responding as much to this price change from the tax. So producers are going to bear more of that burden. So if we think about the answers that we have here, is it going to be that consumers or producers bear more of the burden? Well, this one kind of is easy. Not enough information. We've attended class and we were there for the discussion. We should know that we can determine it. What would have to be true if they share the burden of the tax equally? I would have to have the exact same elasticity, so like negative 0.5 and 0.5. There they would share it evenly. So I know that it's going to be one of these first two because those aren't the same value. This represents being more, even though both supply and demand here, it's an elasticity less than 1. They are both inelastic, but who bears more of the burden is going to be whoever is more inelastic, whoever's more inelastic. In this case, supply, so producers are going to bear more of the burden of that tax. Okay. Any questions on that one before we keep moving? Any other problems people want to see worked through here? Done a lot of the newer stuff. Is there anything from the older stuff people want to see me work through? 19. So let's look at 19. So I think I worked through this one earlier. No, I did not. So assume that you can only buy 2 goods. You've got income of 300, textbooks are 100, pizza's 20. What's the slope of the budget line? So this one, it matters what good we put on the x-axis. So in a question like this, I make sure I specify which good you should be thinking about on the x-axis. Okay. So I want to know the slope of the budget line. Okay. It's always going to be the relative price of the x-axis good over the price of my y-axis good. Okay. So I would write this down. And I know it's tricky that when we calculate the slope, so I'll write these numbers down to make this point because I want to make sure that this is clear going into that exam. So I've got income of 300, textbooks 100, pizza 20. Okay. So I don't really need to do any additional kind of work here. I was told that I think textbooks were on my x-axis. Just double check this. Yes. And then pizza was on my y-axis. So the slope of my budget constraint should always be negative the price of the x-axis good over the price of the y-axis good. So the price of a textbook over the price of pizza. So in this case, it should be negative what? 100 over 20 or negative 5. That's the question, right? I've already answered that. Okay. Once again, I'm not, the slope should always be negative here. When we talk about the slope of the budget line, it's always a negative value. When I start to talk about the marginal rate of substitution, that slope of the indifference curve, we generally are just talking about its magnitude. I'm never going to kind of give you negative and positives in the same thing. I'm not going to try to trick you with that. Not that I'm ever trying to trick you, but I don't know. You might see that from other study materials from other courses or professors. Now, why is this a little bit tricky? Is it a little bit difficult to remember that the x-axis good goes on top? Well, because if I was using quantities, if I'm only buying pizza, how much could I afford to buy? $300 over 20 or 15. If I'm only buying textbooks, how many can I afford to buy? 300 over 100 or 3. So if I use my quantities, because that's the change in my quantity of the Y good over the change in the quantity of the X good, well, going between these 2 points, I would have what? Negative 15 over 3. I get the same value of negative 5, right? But when I'm using quantities, Y was on top. When I'm looking just at the relative prices, I'm going to have X on top. So in fact, if I didn't tell you income and you couldn't solve for the slope finding these quantities, you had to remember that it was the relative prices, you still could. I could have actually just given you this information and you could have told me what the slope of that budget constraint was. Okay. Any other problems people want to see worked through here? Oh, almost requested signatures. Okay. I think this one might be worthwhile to work through. So let's say I had an example like this, and I give you a tax. So if I have this tax, first of all, what's the value of this tax? Well, I didn't tell you the intercept here. I know it kind of looks like this 40 is only going with this dashed line. So the value of the tax is the difference at any quantity between my supply curve with the tax and just my supply curve. So here, the marginal cost of the 60th unit was 40. That must mean that when the supply curve plus the tax is 80, the value of that tax must have also been $40. Okay. Now, what is the deadweight loss associated with this tax? Well, we said we have taxes, price ceilings, price floors, effective price ceiling and price floors. It always reduces the quantity. Right? In fact, we said that was one solution to goods that had negative externalities. If we wanted to reduce the quantity, we could use either taxes, price ceilings, or price floors. So the deadweight loss is going to come from the fact that, well, when I'm at this lower quantity of 60, what surplus is my economy missing out on? Well, the surplus that would have been generated from all these additional 40 units. What is surplus to the market? Well, surplus is always just going to be the difference between marginal benefits and marginal costs. Now, if we were breaking this down to like producer surplus, we said, okay, what's the marginal benefit to producers? That's the price. Marginal cost, that's their supply curve. So that was why it was the difference between the equilibrium price and the supply curve. And then for consumers, what was their surplus? Well, it's still the difference between marginal benefits and marginal cost, but the marginal benefit to them, right, is represented by the demand curve. The marginal cost to them is the price. So that's why for consumer surplus, it was just the difference between the demand curve and the price. But for the entire market, the surplus we're missing out on, or that would be our deadweight loss, is just going to be the difference between the marginal benefit represented by the demand curve and the marginal costs represented by the supply curve for all of those 40 units that we're no longer seeing produced. So it would be this triangle here. Height of that triangle is what? The value of the tax always, so 40, right? The width will always be the number of units that have been reduced because of the tax. So 40 times 40, it's a triangle, so we have to multiply it by 1/2. We're keeping supply and demand linear here. So that difference in between the marginal benefits and marginal cost, 40 times 40 times 1/2 should be 800. Okay. Now, if I'm asking you about what is the new price that consumers will pay after this tax, the new price consumers pay will be where the new supply curve plus the tax hits my demand curve. So consumers will pay $80. However, when we have a tax, we start to have a difference between the price consumers pay and the price that the sellers actually keep. So when I hand over $80, the producer has to instantly pay 40 of that to the government, right? There's a $40 tax on every single unit sold. So the seller only gets to keep $40. Okay. So the price the consumer pays will be 80. The price the seller keeps will be 40. Here we're just asked about the price the consumer pays, but I could ask you about the price the seller keeps. what is the tax revenue generated? Well, once I identify the value of that tax, which will always be the difference between the supply curve and the supply curve plus the tax, I also have the quantity sold after the tax is now only 60. Well, if there's 60 units being sold, every unit, there's a $40 tax. 60 times 40 should give me that tax revenue of 2,400. I don't multiply it by half because notice the visual, this is not representing, I'm at a point where I'm not using that, downward sloping supply demand curve. It's just a rectangle, so I don't multiply that by half. Okay. Any questions over anything there? One thing I would also maybe pay attention to in these problems, or go back and review the quiz questions from this module. Sometimes we have effective price ceilings or price floors. Sometimes they're ineffective. So let's say I had this example and I told you what is deadweight loss if there's a price floor of $40. So you might, okay, price floor of 40. Okay, the quantity will be not 60. Oh, it's going to be the same deadweight loss as we had before. No. If I tell you it's a price floor at 40, that's telling me I can't charge a price below 40. Before that tax, what was the equilibrium price? 50. So was that below 40? No, this is an ineffective price floor, which means nothing will happen and the deadweight loss in the market will actually just be 0. Right there, we won't move away from that equilibrium point. Okay, so make sure when you're asked about price ceilings or price floors, first check to make sure they're effective. Okay, I think a lot of the examples up here, I'm talking about effective price floors or ceilings, but you could be given an example, and I think there's one on either the practice problems or the actual quiz from this module where I give you an example of an ineffective price floor or an ineffective price ceiling. Any other questions people want to see worked through? We got some time here. Let's see. So let's look at, let's think about a positive externality and some additional types of questions I could ask you related to that. All right, so here I'm just asking you about what the social deadweight loss is and how we can correct for a positive externality. So if I have a positive externality, how are we going to model that? Okay. So we said for any product, got my supply curve, upward sloping represents the private marginal costs. Demand downward sloping represents the private marginal benefits. Here, my equilibrium price and quantity is where supply is equal to demand. If I have positive externalities, we generally will model those as additional benefits, right? So we said at every quantity, the benefit to society or the marginal social benefit would be higher. Okay. So right away, we might think about, okay, this is a good thing. If we have positive externalities, I mean, how could we even have deadweight loss? Well, the market doesn't take those into consideration and would stop at this equilibrium quantity. We know that the quantity that the society would want is up here where society's marginal benefits are equal to, with no negative externalities, society's marginal costs. Okay. So every quantity here in this range is something that would benefit society, right? Or we can think about what is the surplus to society here? Just that difference between marginal social benefits and the marginal social costs. However, the market stops down here for every unit in this range. What's the difference between the marginal social benefits and the marginal social costs? That would be represented by this triangle up here. Okay. So if I had some actual values, if I gave you a graph, you should be able to compute this deadweight loss. Now in this problem, it just asked you whether or not it existed. Well, yes, With a positive externality, if nothing is done, we're going to have some, greater than zero deadweight loss to society. Okay. Now the market won't have any deadweight loss, but society will. Okay. So how can we correct for this? Well, we said the only real tool we had that we talked about that can force the market to increase quantity would be if we impose a subsidy, right? So that we get the demand curve plus the subsidy to match up exactly with, so this would be like the quantity after the subsidy, exactly match up with society's desired quantity. Okay. What should the value of that subsidy be? Exactly equal to whatever the value of that external benefit is. Okay. Any questions there? Like I said, I kind of added some stuff in here, but should be something you know. I think for some of the module 7 questions, I would really make sure these are a good set of basic questions. I would go back and make sure I'm reviewing the quizzes though as well. The quiz questions from module 7 might be a little bit more beneficial when we're thinking about questions you might see on the exam. Okay. Okay. I would also make sure I know how to identify types of goods based off of their characteristics and their traits. So I review that. Trying to think of anything else from this chapter that we might want to talk about. So let's say instead I have I had that positive consumption externality that we were just talking about. Another thing I could ask you to do is compare the market equilibrium price to the society's desired price. So when you're doing that, you should always model, right? And I think I showed you in class you can model them differently and you get similar results. But for the sake of the types of questions you'll see, this was also true on the quiz for that module, I'm always assuming that we're modeling society's additional benefits through that demand curve. So our social benefit curve would be higher when we have positive externalities. So what does that mean is also going to be true about the price society wants? Well, not only does society want a higher quantity, they would also want a higher price for this good when I have a positive externality. Okay. Wink, wink. I could also ask you a similar question. So, I don't give you the exact same questions here. And anytime I'm reviewing for this exam and I'm looking at a question, I would think about like, okay, what could be changed? Increase instead of decrease, supply instead of demand, etc. So if I have a market that's currently in equilibrium, and instead of a positive externality, let's assume I have a negative externality. We said, how do we model those? Always through our supply curve because it's an additional cost to society. So at every quantity, if I've got a negative externality, marginal social cost will be higher. We don't have any positive externalities, so my marginal social benefits the same as my marginal benefits to the consumers. So where would that efficient point, or where would surplus be maximized for society? Well, once again, this is kind of intuitive, but if there's a negative externality, society is going to want less of that, right? As a result, because it was overproduced, right? We said, what's the deadweight loss? That's the difference between the marginal social benefit and the marginal social cost to society. However, when we have a negative externality, the market is producing too many, which means for every unit in this range, what's true about the marginal social cost relative to the marginal social benefit? It's actually greater. So the deadweight loss comes from the fact that when we overproduce, there's negative surplus to society from all of these units, right? So this would be kind of our deadweight loss that exists with a negative externality. And then for the price that society would want, well, that equilibrium price that would result in the quantity that society wants would actually be a higher price. So in both scenarios, that equilibrium price of society would like for that market is going to be higher. Okay. Any questions on that idea before we keep moving? Okay. right. Any other questions that people have from this? Could be on other stuff too. Doesn't just have to be the practice exam, or maybe just have a question in general. I know we've kind of hit the end of class here, 12:30, but because of that slight interruption, I want to make sure I give a couple minutes to answer a question here. Okay. All right. So just to kind of recap and kind of give us one more announcement about this exam, I would use this practice exam. I think it's a very good representation of the kinds of questions you'll see. One thing that we didn't do today, I would feel comfortable with, is having a table like this and being able to find the missing values in different points. So even though you only have questions about a couple of those points, maybe try to solve this entire table, right? That would be maybe something I would really try to do. Okay. So modules 5 and 6, 7, 8, and 9 will all be on that exam. This practice exam is really good, preparation for it. I would go back and review the quizzes. So because those 2 quizzes aren't due until the end of the day today, it's kind of difficult to do that for modules 8 and 9 until after the due date passes. So you can kind of take a look at those answers, review the ones that you got correct or incorrect tomorrow before sitting down to take the exam. I would look at the practice problems from modules 8 and 9 if you're wanting some additional review there. I would then also go back. You should be able to review module 5 and 6 and 7 quizzes. That due date is passed, so you should have time to kind of review those. Other than that, make sure you test that lockdown browser and let me know today immediately if you have any issues with it so I can try to get that resolved by the time we start that exam tomorrow, which is 11:15 and open until 3:15. Okay. Any questions logistically about the exam for me before we end this video? Okay. All right. Well, good luck tomorrow. We will then start Monday's class. I'll put up the module 10 reading tomorrow. Once the exam is done, you can kind of start thinking about doing that over the weekend before meeting class on Monday. Okay. All right. Well, good luck tomorrow. And if you have any questions, I'll be up in my office, so we can also kind of meet during office hours here the next hour and a half.